Hello, Sarah Miller here. Today we'll be looking at the Alka-Seltzer lava lamp. So what exactly makes this thing so bubbly? Let's start with the components. The bottle is filled with 1 part water and 3 parts cooking oil. The oil is less dense than water, so it sits on top of the water instead of mixing with it. Next, we add some red food coloring for awesomeness. Then we can add our Alka-Seltzer tablets to the bottle as seen in the video. Wow, there's a lot happening there. So what's in the Alka-Seltzer? According to the box, in each Alka-Seltzer tablet, there's 1,000 milligrams of citric acid, 325 milligrams of aspirin, and 1,916 milligrams of sodium bicarbonate. When we plop the Alka-Seltzer into the water, the bicarbonate ions from sodium bicarbonate react with the hydrogen ions from citric acid, and water and carbon dioxide are formed. The carbon dioxide is what causes the bubbles. This reaction equation can be summarized here on this slide. And since we know that sodium bicarbonate and citric acid are stoichiometrically even, we can calculate molarity to determine which is the limiting reagent. So we know from the calculation that the molar mass of citric acid is 192.124 grams per mole. And so if we calculate that out to moles, we get from the weight from the box, we get 0.005 moles. So that's for citric acid. And then if we calculate the molar mass of sodium bicarbonate, we get 84.007 grams per mole. And so if we calculate out the moles using the mass from the box, we get 0.0228 moles. So based on that data, we know that the citric acid is actually the limiting reagent. So that's good to know. Now, if we wanted to get really crazy, we could maybe even switch out the water for vinegar and see what happens then. My hypothesis is that the extra protons from the acetic acid will make it so the bicarbonate is the new limiting reagent. And this is because the acetic acid will the acetic acid will donate extra protons. And yeah, that'll make the sodium bicarbonate the new limiting reagent. And the lamp will get even bubblier because there's more reagent available. But that experiment is for a different day. And thank you for listening.